Good morning, AP Physics. I hope we're ready to do some Kirchoff loops. I am all ready with my Calamity Disaster mug. Thought it very, very appropriate as I broadcast to you from my living room. Okay, so let's get into it. First of all, you should look at the PowerPoint that I have on my teacher page on Kirchoff loops first. Then we'll get into the solving of this. So put me on pause, then go look through that PowerPoint. Okay, I'm assuming that you have looked through the PowerPoint and know what the junction rule and the loop rule are. So now let's get started with this circuit here. We want to analyze this circuit and find out what the current is in each branch of the circuit. Now you're going to first notice that you have got two different batteries. Now remember that the long end represents the positive terminal and the small end represents the negative terminal. Typically, current flows negative to positive. So I'm going to assume that on this first branch, my charge is, or my current is flowing in this direction. I'm going to call that I1. And here I'm going to assume that current is flowing in that direction. Now that's just an assumption that I make. I'm going to call this one I3 because it's on the third branch. My assumption could be entirely incorrect, and we'll figure that out at the end. Now you're also going to notice that I have two nodes, two junctions is what we refer to them as. I'm going to call them junction A and junction B. Current is flowing into junction A and out of junction B. That's going to give me my indication of what current 2 is. Because it flows in, we have to have current flowing out. That's what our junction rule says to us. So in junction A, current 1 plus current 3 has to be equal to current 2. And if I look at junction B, that basically says the same thing, but in reverse. Here we have current 2 flowing in and current 1 and 3 flowing out. So in B, I would just write this backwards. It means the same thing, as you know. So now that I know this, now if I can figure out what current 1 and current 3 are, I know what current 2 is. Or if I know current 2 and current 3, I know for current 1. You get the idea. So now let's see if we can figure out what those currents are. Now, the other part of Kirchoff's rules is the loop rule. That says, if I can change color here, let's see if I can grab red. That says, yes, I could, that when we go through a loop, all the currents should add up to 0. Or excuse me, not the current, the voltage should add up to 0. So I'm going to look at two loops here. Now we've actually got 3 loops. We've got loop 1, which is this intersection, okay, involving current 1 and current 2. We've got this intersection involving current 2 and current 3. And we've got a big outer loop as well. Now, experience is going to tell you which loops to pick, but for now it doesn't really matter, and we only do need to pick 2 of them. Okay, so I'm going to go with first this loop involving my 12 volt or my 1.5 volt battery. So I'm going to start at B. You could start anywhere along that loop. It's up to you. But I'm going to start here at B. When I come around my loop, the first thing I encounter is my battery. And I encounter that battery from negative terminal to positive terminal. Which is the appropriate way to encounter it? So that's going to be written down as, okay, so this is for loop 1. That's going to be written down as positive 1.5 volts. Okay. Then I come to A, and I'm going to follow current 2. Current 2 is then flowing through my 100 ohm resistor in the direction that the current travels. So that's going to be negative I2 times 100. And then I get back to B. When I get back to B, I'm going to say equals 0. Now this is a simple algebraic problem. I can easily solve this. Okay, so that's going to give me 1.5 equals positive 100 times I2. So that means that I2 equals 0.015 amperes. Or if I wanted, I could say 15 milliamps. So now I know what I2 is. 0.015. Okay? Now I'm going to go to my second loop. Again, pause this at any time, rewind it if you need to go back and see what else you need to review. So I'm going to change colors here. I'm going to get green. And now I'm going to do this loop. Okay? But I'm actually going to do it in that direction. Again, negative to positive. All right, so loop 2. So I'm going to again start at B, come around, and the first thing that I encounter is a 200 ohm resistor. So that's going to be negative I3 times 200. Why is it negative? Because I'm going in the direction of the current flow. If you go in the direction of current flow for resistors, it's negative. If you go from negative to positive with the batteries, it's positive. So now I come to a 12-volt battery. No, I keep saying 12 volt, but it's 9 volt. And I am in the direction negative to positive. Okay, now I encounter my junction A, and now I'm going to follow this loop down. So 100 times I2, I'm in the direction of the current flow, so that means it's negative. So minus I2 times 100. Oops, it's still the eraser. 100 equals 0. But I already know what I2 is. It's 0.015. 0.015 times 100 is 1.5. So I can rewrite this as negative 200 I3 plus 9 minus 1.5 equals 0. 9 minus 1.5 is 7.5. So I can say 7.5 equals 200 I3. And if I hit that into my calculator, I get that I3 is equal to, let me bring up my calculator real fast. .5 divided by 200 equals 0.0375 amps. So now I know what I3 is. So now I can find I1, which is this current in my first branch, by just doing some simple algebra. And I am going to bring my page up a little bit. We said that I1 plus I3 was equal to I2. We said that I3 was 0.0375 and I2 is 0.15. So that means that I1 is equal to 0.015 minus 0.0375. .015 minus 0.0375 equals negative 0.0225. We got a negative there. That tells me that when I look back at my circuit, I had I1 going in the wrong direction. I1 should be going in that direction. The number is still correct, but I just had the current going in the wrong way. How can that be when it is negative to positive? Well, take a look here. This battery was so much more powerful than this one that current just pushes its way along and forces it in that direction. So really what we should have said at this junction was that I3 equals I2 plus I1. Okay, and here in this direction, at this junction, I2 and I1 together give us I3. Okay, well, this is the first video that I have for you. I am going to do another one to show you how we can use this again to find the power or EMF of the battery. Okay? All right, I'll talk to you in a little bit.